Inside the ion, we have amino acids and chlorine ions. We also have potassium ions within the axon and outside of the axon. Outside of the axon are also many sodium ions. This is the process of depolarization. Sodium ions enter the axon through special ion channels made just for them. This causes the cell to become positive. This is the process of repolarization. Potassium ions leave the cell through special potassium ion channels to make the cell become more negatively charged. This is the process of recovery. The sodium-potassium pump will reverse sodium and potassium concentrations. This process requires ATP and reverts the axon to homeostasis. This is the synaptic jump. Sodium and potassium ions travel down the axon, causing calcium to enter the axon. This goes into vesicles containing neurotransmitters and causes them to break open, and the neurotransmitters cross over to an interneuron receptor. The process of depolarization is now repeated in the interneuron axon. It becomes positively charged. Now repolarization occurs. Potassium ions again leave the axon and it becomes negatively charged. This is the process of recovery. The sodium-potassium pump will reverse sodium and potassium concentrations. The potassium pump can either hold 3 sodiums or 2 potassiums, but not at the same time. Now we go through another synaptic jump. Wave movements bring the sodium and potassium down the cell and again cause the release of calcium into the axon. Now we are in the muscle neuron. We again go through the process of depolarization, where sodium enters the cell and causes a positive charge. Now we again go through repolarization, where potassium ions leave the cell and bring it back to a negative charge. Wave movements travel down the axon, bringing the potassium and sodium ions. They head down the dendrites and into the muscle.